Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today our discussion topic is chapter 8.2. It is in your statistics part. Dear students, you have already understand that statistics is totally depending on your concept. If you have the very clear concept in the theorem part, then mathematical part is very easier for you. And today our mathematical topic for understanding will actually discussing about Lami's theorem. If you can understand the Lami's theorem and why and how and which way Lami's theorem has been proved, then our mathematical part will be again very easy. Let's have a look at our today's class. So dear students, according to our lesson plan, today we are going to discuss about some basic part of 8.2, and first mainly we'll going for to understand the Lami's theorem. To understanding the Lami's theorem, we need to understand first the triangle's law of equilibrium. Triangle law of triangle's law of equilibrium. What is actually this law has been expressed? To understand this part, we have to assume that three force will acting at a same point. Say for example, that is the fixed point where there is working three forces. Say for example, this is the force in this area. Actually P force has been acting on this word, Q force has been working in this way, and R force has working at that direction, and all these three forces actually working on this point. If it's happening, then what actually we can say? From that part we can say that this actually represents three forces in a triangle. How? Here P force is working this word, that means the force P has been working this word. Here Q has been working this way, so we can write that this Q force has been working in this direction, and R force is here, that means the R force has working this word. Then actually we get a triangle. Okay, this actually looks like a triangle, and according to the triangle's law of equilibrium, we can say that it is P plus Q plus R is equal to 0. That means the force of 3 is equals to 0. Since all of this actually represented the direction, that's why this is a vector component, so it should be P plus Q plus R. But my dear students, we know from the triangle's law that generally two forces addition should be the equal to the third part, isn't it? If that, we have to actually understand this triangle very closely, that where the direction has been working. Here the P force is working this word, Q force has been working this word, and R force has been working that word. That is, this flow is in the same direction, that's why it should be 0. To understanding this part very clearly, we are thinking that, say for example, all the vertices are, say for example, A, B and C. Okay, so we are just thinking that this actually R forces are not acting this way, rather it has been working in that word. If this, then here the flow has been going this word, and this has been restricted. So according to our triangle's law, we can write from here, that is P plus Q should be R. P plus Q should be R, because now we are thinking that R is not that way, rather R has been working in that word. Okay, to understand this part very clearly, we can write with this direction. Say for example, it is CA plus AB is equal to R, that is CB. Okay, now actually taking all of that in the same side, it can be CA, AB plus CB, and we know CB can be replaced by BC. So CA plus AB plus, it should be actually what? Since it was plus, so it has been coming in left side, so now it is minus. Now CB can be written as minus BC. Now what's the value of CA, AB and BC? CA is actually the P direction, so it should be P plus, here it is Q, because AB, now it is BC, so it is going this word, that's why you have to write this is the our what force. So we can write here it is equals to, since minus minus is plus, are forces. Since all of these forces addition is 0, then we can say that this is the triangle's law of equilibrium. If three forces are remain on the same point, then and if they are equilibrium, then we can say all the forces addition should be equal to 0, or the sum of the forces is equal to 0. So this is the law of equilibrium, and from here we are trying to understand the Lami's theorem. Clear? So dear students, now we are going to discuss about our main topic, that is the Lami's theorem. What actually the statement has been talking about? The statement of the Lami's theorem says that if three forces acting simultaneously at the point, at a same point along three different lines in equilibrium, those three lines must be in equilibrium. The magnitude of each forces is proportional to the sine of the angle between the lines action of the other two forces. That means the opposite of that forces. So maybe you can't understand anything from this statement, but I am trying to actually broke down all the points one by one. Here the question or the statement of the theorem of the Lami says that three forces must have to be acting at the same point. So our forces of the equilibrium theorem or the triangle's law of equilibrium, that was the same thing, that we also working at the same point. So here three force has been acting simultaneously at the point. That means here this is the force P, that's the force Q, and here the force R. So here three forces are acting at the same point. Okay, if this, then this will be in equilibrium. That means what? If three actually forces are remaining in equilibrium, it remaining is, we have already known that is actually P plus Q plus R. So this is actually given. This is actually given because these three forces are in equilibrium. Okay, if this, then the magnitude of each forces is proportional to the sine of the angle between the lines of action of other two forces. That means this force, okay, this force should be proportional to sine of the opposite two other two forces. That means it should be proportional to sine of, say for example, this is the angle of alpha. Okay, then Q will be proportional to, Q is here, so this is its opposite, that means it is, say for example, beta, so Q should be sine beta. And here R, and this is the opposite, so say for example this is gamma, so R is proportional to sine gamma. Okay, and from here what we can write actually? From here we can write this is actually P should be K sine alpha. That means P over sine alpha should be K. Then Q equal to K sine beta. That means Q by sine beta should be K. and r equal to k sine gamma, that is r over sine gamma should be k. Okay, since all these three ratios is equals to a same constant part, so we can say actually from these three parts is finally p over sine a, I mean sine alpha, q over sine beta, r over sine gamma. So actually this we can write this line according to our Lami's theorem. So actually Lami's theorem is something like this, and this will be happening on that times if p q are in equilibrium. Clear? Okay, maybe one question arises in your mind that why we can write this part, and what's the basic relationship with this part with the triangle's law of equilibrium. To understand that part, we have already known from here we can write a triangle, and that triangle looks like that part it was P, then that part it was Q, and that part that was R. And since it was P and Q, the angle was gamma, so PQ angle should be gamma. Then QR, the angle of QR is alpha, and RP, the angle was beta. Okay, from here we can write this is the angle, it can be written as 180 degree minus alpha gamma, it is 180 degree minus alpha, and this is 180 degree minus beta. Okay, from here we can write another line, and that line can be written as, just I am erasing up to this part because you have already understand this part, but this line will be remaining. Okay, and from triangle what you can write? Okay, so from here we can write according to the sine rules. We know the sine rules, so from this triangle according to the sine rule we can write that our this P force should be, actually P is this force, so the opposite of that force is this, so sine 180 degree minus alpha. Q force, here the Q force, so no relation with that, so it should be sine 180 degree minus beta, and R force, this force, no relation with this angle, so it should be 180 degree minus gamma with sine. Okay, so my dear students, we all can understand I think that how actually from this law of triangle if we use from here, because all these three are remaining equilibrium part, so from here we can also prove the Lami's theorem too. So in both way actually this or this we can solve the, or we can understand the Lami's theorem. So mainly our Lami's theorem is this, but if anyone write this way it is also correct, because we know that this is actually sine 180 degree minus alpha, that means it has been remaining actually 180 degree minus alpha, it has been remaining in the second quadrant, that means from here we can write it is actually P over sine alpha, Q over sine alpha. No ratio will be changed because it is 180 and it is in the second quadrant, and it is actually the positive of sine, that's why it is the sign should be remain positive. So finally we get the Lami's theorem. Okay, so my dear students, that was the Lami's theorem and converse theorem of Lami. So the Lami's theorem converse proof should be actually the different thing, that is this part will be given, and from here we need to prove actually P plus Q plus R equal to 0. From here we need to prove this. If we can going for that way, then our converse theorem will be also proved. So that is our basic concept of Lami's theorem. Now let's actually solve a math from this part. So dear students, our today's problem regarding actually Lami's theorem is example 1. The question says the forces PQR these are the forces acting at the vertices of ABC of a triangle ABC. Okay, so they are acting on the three vertices along perpendicular to the opposite sides, respectively are in equilibrium. Then we need to prove P is to Q is to R equals to A is to P is to C. Okay, to understand this we need to actually draw a figure first. Okay, our solution should be like that way. So for example, here our question says we need to draw a first triangle, that is A B C triangle, and from these three vertices we have to actually draw three perpendicular from these vertices. So from A we draw a perpendicular on the other side, from B, and say for example from C. So we are drawing the perpendicular. Okay, so all of these actually the perpendicular, that means all of that are the 90 degree. Okay, now here all of these three can be denoted by P, Q and R. So say for example, this is the side where P has been working, here Q has been working, and on that line R has been working. Now our question says if these are in equilibrium, that means all are actually equilibrium, that is the P plus Q plus R should be 0. If that, then P is to Q is to R equal to A is to B is to C, we need to prove. Okay, for this what we can write, we have already given a triangle, we had drawing, three perpendicular has been given, so we can give a name of that. Say for example, this is actually AD, BE and CF. Okay, and now what we can write from here, we can write, so since P has been working this way, so we can say that P is working actually this word, Q is say for example here, and R say for example in here. Okay, so why we are going for that word, because we need to write something according to the Lami's theorem. What you can write, according to Lami's theorem, what you can write, here our P force has been working that word, so the opposite should be this, so P over sine this angle, that is D, say for example that is the point is O, so DOF, then the angle Q over here is working the angle, so it should be that angle, that is DOF. It was EOF, sorry, it was EOF that angle, and it is DOF this angle, and R is angle working that word, so it should be this angle, that is DOE. So according to Lami's theorem, we know that force is proportional to the opposite angles or the angle which will be creating others two. So R should be creating the P and Q is this angle, so it should be P over sine this angle, Q over sine this angle, and P over sine that angle. Okay, from here we'll now we'll just going for a quadrilateral. Now from quadrilateral FOEA, what we can write, since these two are the perpendicular, that means these two actually the 90 degree, so we can write that these two should be 180, this angle and this angle should be 180. Why? Because all of that four angles summation should be 360. Already this and this has been creating what, these two opposite angle has been created 90 and 90, 180. So that must be actually this angle and this angle should be, the sum of that two should be 100. So A angle plus here EOF, these two angles will be creating 180 degree. Why? Because we have already known that these two, I mean BE is perpendicular on AC and OF perpendicular on AB. Okay, from here we can say that our this angle, that is EOF, is 180 degree minus A angle. Okay, so what should be this? This angle is 180 degree minus A, so this angle should be 180 minus B. So similarly, angle DOF should be 180 degree minus B, and this angle, I mean DOE, should be 180 degree minus C angle. Now if we putting all of these three, that is this, this and this, in equation number 1, then what we will get? If we putting all of that value in here, then we can write P over 180 degree, I mean sine 180 degree minus A angle, then Q over sine 180 degree minus B angle, and here it should be R over sine 180 degree minus C angle. Okay, so because we have already found these three values, just putting all of these values in here. Now if we calculate, then what we can write from here? We can write, obviously it should be P over sine A, Q over sine B, R over sine C. Okay, we can write P over sine A, Q over sine B, and R over sine C. So now we have found last this line. Okay, so what is the formula of the sines rule? We know the sine rule is, so we can write from here that from sine rule A over sine A, B over sine B, C over sine C. So if we giving this as 2 and this is our 1, then from 1 and 2 what you can write? From 1 and 2 what you can write? We can write by this and this, P over A, Q over B, R over C. That means P is to Q is to R should be A is to B is to C. That's our required proved. So just we have used this and this, and just comparing these two part, we have actually written this part. So this is the end of our today's math. So dear students, hopefully this lecture will be very beneficial for you. Since today we have been discussing some theorem as well as one math regarding on sine rules, I mean the Lami's theorem. So hopefully this lecture will be very crucial for your understanding the next mathematical problem. So that's all for today. Thank you.